The second one, limit of which function as x tends to a? The function is 1 upon x cube minus 3ax plus 2a square. Actually, this should have been x square and not x cube. I'll make a correction here. This is x square. So 1 upon x square minus 3ax plus 2a square plus 1 upon 2x square minus 3ax plus a square. Now the same logic. Can we take the limit in the very first step? The answer is no. Why? Because if you replace every x by its limiting value, you get 1 upon 0 plus 1 upon 0. For God's sake, don't say it is 2 upon 0. That is absurd. But you will notice that as denominator is 0 at x equal to a, x minus a is its factor. If we know one factor, second factor can be written by observation. How? X into which term is x square? X into x is x square. Simple. Minus a into which number is plus 2a square? Minus a into minus 2a is plus 2a square. So I got the second factor. See, limits is not difficult. What is difficult is factorization, using trigonometric results, using laws of logarithm. So that part is very important. Consider the second denominator. Again, x minus a is first factor. X into which term is 2x square? X into 2x is 2x square. Minus a into which number is plus a square? Minus a into minus a. As simple as that. So this is the second factor. Now, how do we add two fractions? By finding LCM of denominators. What is that? X minus a into x minus 2a into 2x minus a. What is the numerator? 2x minus a plus x minus 2a. That is 3x minus 3a. Take 3 common from numerator to get 3 into x minus a. Denominator as it is. Many students have tendency not to write limit x tends to a in all the steps. That is wrong. See, when you do not write limit x tends to a, means you have evaluated the limit. And when you evaluate the limit, how can x be there? So you should write limit x tends to a in all the steps unless and until you take the limit. See, you are not solving MCQs. While solving MCQs, it's okay if you do not write lim in all the steps. Now, can I cancel x minus a? Yes, I can. In fact, x minus a is giving 0 by 0 form. Now you have to justify why you can cancel x minus a. What is the justification? X only tends to a. X is not equal to a. As x is not equal to a, division by x minus a is not defined. Is that clear? After cancelling x minus a, mention the remaining factors. They are 3 in the numerator and this is the denominator. Now can we take the limit? The answer is yes, we can. To take the limit means to replace every x by its limiting value, which in this case is a. So a minus 2a, that is minus a. 2a minus a is a. So it is 3 upon minus a square, that is minus 3 upon a square. A good student will write final answer in this form, that L equals what? L equals minus 3 upon a square. This is the correct method to mention the final answer. I hope that you have understood this. See, limits is very interesting. Now, this is the next sum. Limit of root of 3x plus 1 minus 4 upon 7 minus root of 8x plus 9. I will again read the sum for you. Limit of which function? Root of 3x plus 1 minus 4 upon 7 minus root of 8x plus 9. Can we take the limit? The answer is no. Why? Because even if we take the limit in the first step, we get 0 by 0 form. You can verify this. Put x equal to limiting value, which is 5. So 15 plus 1, 16. Its root is 4. 4 minus 4, 0. What about denominator? 8 into 5, 40 plus 9 is 49. Its square root is 7. 7 minus 7 is 0. So in this case, you have to rationalize the denominator and numerator also. See, the logic is simple. I won't say this is a polynomial, but value of both numerator and denominator is 0 at x equal to 5. So x minus 5 must be the factor of both. Dear friends, initially that factor is in hidden form. So we have to find that factor, and after taking that factor common, we have to cancel it. For that, the only option is you should realize that you have to rationalize. So rationalizing both numerator as well as denominator. Now what do you mean by rationalizing numerator? By rationalizing numerator, we mean multiplying both numerator and denominator by rationalizing factor of numerator. I'll explain. See, many students, they think that, sir, you said rationalizing numerator. We got this also, that what is the rationalizing factor of this? It is root of 3x plus 1 plus 4. But you have multiplied denominator also by that. Dear friends, if you just multiply numerator by any number or term, the function will change. So though you say rationalizing numerator, you have to multiply denominator also by that. Is that clear? So why I have taken this? Because I want to rationalize numerator. Why to write this factor? Because this is the rationalizing factor of denominator. So basically it should be present in the denominator. But we cannot just multiply denominator, otherwise function will change. So to make hisab barabar, we have to multiply numerator also by the same. Is that clear? But while taking the product, we will consider first and third in the numerator and first and second in the denominator. Now, this is of which type? First minus second into first plus second. That is a minus b into a plus b. What is that? It is a square minus b square. So it is what? 3x plus 1 minus b square, that is 4 square. Remember, 7 plus root of 8x plus 9 as it is. What about denominator? Again a minus b into a plus b, which is a square, that is 7 square, minus in bracket 8x plus 9. Why to put this in bracket again? Because there is negative sign before that. This term as it is. Now 3x plus 1 minus 16, that is 3x minus 15. This is 49 less 8x less 9. So this is nothing but 49. I have written that step, minus 8x minus 9. That is 49 minus 9, which is 40 minus 8x. In this step, you will notice that from 3x minus 15, I have taken 3 common to get in bracket x minus 5. Denominator is 40 minus 8x. I have taken minus 8 common and not 8. Why? Because I want x minus 5. Simple. This term as it is. Now we have got the factor which we are looking for, x minus 5. Now can I cancel x minus 5? Yes, I can. Because x only tends to 5. X is not equal to 5. So division by x minus 5 is valid. After cancelling the factor, you have to mention remaining terms. Now can I take the limit? The answer is yes. Why? Because when I take the limit, I replace every x by its limiting value, which is 5, and denominator in that case is non-zero. So what happens when I take the limit? 3 into 7 plus root 40 plus 9 upon minus 8 into root of 15 plus 1 plus 4. That is 3 into 14 upon minus 8 into 8. Why 8? 15 plus 1 is 16. Its root is 4. 4 plus 4 is 8. So on simplification, I get minus 21 upon 32 as the final answer. Again, I will write this answer as L equals what? Minus 21 upon 32. It should not go out of the box, right? So this is the final answer. Now, this is again a very important standard limit. Limit of x raised to n minus a raised to n upon x minus a as x tends to a is n into a raised to n minus 1 where n is a real number. Actually, you have proved this result for n to be a natural number, but the result is seen to be true for any real index. Note that this is not na in bracket raised to n minus 1. See, this is different. What does this mean? This means n raised to n minus 1 into a raised to n minus 1. No, the result is n into what? A raised to n minus 1. In order to use this result, the function should be in this form only. If tending value of x is a, it should be x raised to n minus a raised to n upon x minus a. Now we will solve few sums on this particular type. In fact, this is the first sum. Limit of x raised to 7 minus 128 upon x raised to 5 minus 32 as x tends to 2. Now can we take the limit in the very first step? The answer is no, because 2 raised to 7 is 128, less that is 0. Denominator 2 raised to 5 32, less 32 is 0. So clearly we cannot use or we cannot evaluate limit in the very first step. So it should be done. Again, the result to be used is standard limit, limit of x raised to n minus a raised to n upon x minus a. A good student will notice that both numerator and denominator are of which type? They are of the type x raised to n minus a raised to n, but denominator should be of which type? X minus a. If tending value of x is a, this clearly shows that we have to divide both numerator and denominator by what? X minus 2. But is it valid? Yes, it is, because x only tends to 2, x is not equal to 2, and therefore x minus 2 is not equal to 0. So in this step, what I have done? I have divided both numerator and denominator by x minus 2. Now many students have the question, sir, how can we come to know that division by x minus 2 is required or not? See, if you know the standard results, you will come to know that denominator should be strictly x minus 2. Can you see x minus 2 here? No, should provide. But you cannot just divide numerator by x minus 2. The same should be applied to denominator also. And that is why here I have divided both numerator as well as denominator by x minus 2. So in the next step, what is limit of quotient? It is limit of numerator upon limit of denominator. Now, can I use the standard limit? The answer is yes, because this is of which type? X raised to n minus a raised to n upon x minus a, x tends to a. Now what is the standard answer? It is n, that is index 7, this is not the decimal point, into a raised to n minus 1. A means tending value. So 2 raised to index minus 1. Same is for denominator. Here index is 5. So 5 into 2 raised to 5 minus 1, that is 7 into 2 raised to 6 upon 5 into 2 raised to 4. On simplification, you get final answer as what? 28 upon 5. You may convert it into decimals as it is not recurring, it is terminating. So 5.6 can be your answer, or you can write answer in that form. Here I will write it is 28 divided by 5. I hope that you have understood the solution.